folks, Dr. Saul, the solving surgeon, talking to you about solving proportions. Now here's a question. Why did the cookie go to the doctor? Because he was feeling crummy.
Okay, the first thing we're going to do is review a couple vocab terms. So first is a ratio. That's a comparison of two quantities using division. So here we have A divided by B, or A to B. Here we have 3 to 4, or 3 for every 4. 50 miles for every 1 hour, or 50 miles per hour. 50 miles to 1 hour, or $20 per pound. $20 for every pound. These are all ratios. A unit rate, remember, is a rate or a ratio with a denominator of 1. So it's just like what we were talking about, except the denominator, or the right side, are equal to 1. You can see in our ratio, the right side over here is equal to 1 second. So it's 2 yards for every 1 second. 2 yards to 1 second. 43 feet per minute, or 43 feet per every 1 minute. 50 miles per every 1 hour. $20 per every 1 pound. Third vocabulary term is a proportion. That's a statement that two ratios are equal. So all it is just setting two fractions equal to one another. That is what a proportion is. The next vocabulary term is the multiplication property of equality. That's multiplying the same quantity to expressions on either side of the equal sign in an equation. So for example, we have this proportion. Now, the multiplication property of equality says if we want to multiply one side of the equation by 5, it's okay as long as we do the same thing to the other side of the equation. So here, we multiply both sides of the equation by 5, and what happens is these end up canceling out, and we get x is equal to 5 over 6. That's how we solve this particular proportion. That's one way to do that. Another way to solve a proportion would be the cross product property, and that's a method for solving problems involving proportions, and let's show you how that works. Cross product should be pretty self-explanatory. We are going to multiply across. Product means multiply, and cross is just across. So we're going to multiply B to C and A to D, and what you do is you set those equal to each other. A times D is equal to B times C. That is the cross product property.
Now, there are 6 properties of proportions that I want to show you right now. If we are given the proportion that we were using earlier, A over B is equal to C over D, or A to B is equal to C to D. What we can do is rearrange them, and we would get ratios that would still be equivalent to one another, that would still equal one another. And how could you rearrange them so that they would still be equal to one another? Well, let me show you. If we know that A over B is equal to C over D, we know that B over A has to equal D over C. The reciprocals of each side have to equal one another. If we know that A over B is equal to C over D, we know that A over C is equal to B over D. If I were to swap the B and the C, and that makes sense, right? Because even if I were to swap these two and I get A over C is equal to B over D, the cross products will still be the same. A times D will still be equal to B times C. For the third property down here, what I'm doing is just taking the reciprocal of this one. Since we know that these two ratios are equal to one another in this proportion, then we know that the reciprocals of each side must also be equal to one another. For the fourth property over here, we know that this is just the cross product property. A times D has to equal B times C. Over here, this would just be the symmetric property of our cross product property. Instead of having A times D is equal to B times C, we have B times C is equal to A times D. For the sixth property down here, this looks a little confusing. We have A plus B over B is equal to C plus D over D. Interesting. How in the world would this be equivalent to this up here? Well, what actually happens is I'm going to add 1 to each side of this equation, meaning I'm going to add 1 over here and I'm going to add 1 over here. Now, instead of adding 1, what I'm going to do is add B over B. Instead of adding 1 over here, I'm going to add D over D because each of those are equivalent to 1. And when I do that, this is what comes out. I get A plus B over B is equal to C plus D over D. Now, if you ever want to know if another proportion is equivalent to your given proportion, just check to see if they have the same cross product. If I use the cross product property here, I would get A times D is equal to B times C. If I use the cross product property here, A times D is equal to B times C. A times D is equal to B times C. A times D is equal to B times C. Look at that. Each of these cross products are the same, meaning that we know that each of these proportions must be equivalent to our given proportion. And for this last one here, the cross product is actually the same if you were to simplify. If I multiply the quantity A plus B times D, I would distribute the D to the A and to the B. So I would get A times D plus B B times D. If I were to multiply B times the quantity C plus D, I would distribute the B to the C and to the D. So I would end up getting B times C plus B times D. So each side of the equation then would have a B times D that I could subtract out, and I would get A times D is equal to B times C. So again, we get the exact same cross product we got with our original proportion.
Why did the patient make his therapist cry? Because he was trying out reverse psychology. It's example time.
Now example 1 says if x over y is equal to 5 over 6, complete each statement. So here we are given 4 separate statements that we have to complete, and in order to complete them we have to use the properties of proportions. So for this first one we have 6 times x is equal to what? So we look up here, how did we get 6 times x? Well, we multiplied across 6 times x. So this is testing your knowledge of the cross product property. 6 times x has to equal what? Well, it's going to be y times 5, or 5 times y, or 5y. Over here, x over 5 is equal to what? Well, we look back at our original proportion. How did we get x over 5? They did the numerator over the numerator, so that has to equal the denominator over the denominator, y over 6. Down here, we have y over x is equal to what? So y over x would be the reciprocal of this ratio, meaning we have to set that equal to the reciprocal of this ratio, 6 over 5. Lastly, we have x plus y over y is equal to what? So that was the numerator plus the denominator over the denominator has to equal the numerator plus the denominator over the denominator. So 5 plus 6 over 6, or 11 over 6. Remember, you can always use the cross product property to check your answer. If I multiply across, I should get the exact same thing for each of these as I get with my original proportion.
While you're busy filling out all those 20 insurance forms, why don't you also try this?
Okay, doing the same thing here. We're given our original proportion and we're testing our knowledge of the properties of proportion. So we start. A times B has to equal what? Well, again, this is testing your knowledge of the cross product property. A times B has to equal 100 times 60, or 6,000. Over here, A over 60 is equal to what? So A over 60 would be numerator over numerator. That has to equal denominator over denominator, 100 over B. Part C, we have B over 60 is equal to what? B over 60, well, that's just the reciprocal of this ratio, so that has to equal the reciprocal of this ratio, 100 over A. Lastly, we have 60 plus B over B equals what? So 60 plus B over B would be numerator plus denominator over denominator, has to equal numerator plus denominator over denominator, A plus 100 over 100. Don't forget, you can always check your answer using the cross product property. You should get the exact same cross product that you get with your original proportion.
Okay, example 2 says solve each proportion using the multiplication property of equality. So here we have our proportion. Now it says using the multiplication property of equality. So that's one of the ways to solve a proportion. Now when you see this, it's basically just asking you to solve it like you normally would. We simplify, move, solve. So step 1, can we simplify either side? No. So we move to step 2, variable on the left. Done. Step 3, constants need to go to the right. So this 12 needs to go over here. How do I do that? We're dividing by 12. So what's the opposite of dividing by 12? The inverse, it would be multiplying both sides by 12. So we multiply both sides by 12, and I make it 12 over 1 because these are going to cancel each other out. You could also just straight up multiply across like you normally do, here, and you end up getting 12x over 12 is equal to 60 over 6. Now you can see that these actually do cancel each other out, and we're left with x is equal to 60 over 6, which, if we simplify, is equal to 10, and you're done. Now part B, we have 4/5 is equal to A over 8. Now again, since we're using the multiplication property of equality, which is just multiplying the same thing to both sides of the equation, we are just solving the equation. So we simplify, move, solve. Step 1, can we simplify either side? No. So we move to step 2, variable on the left. It's on the right. How do I do that? Well, since it's the beginning of the equation, I can just flip this equation. Done. Variable's on the left. Step 3, constants need to go to the right. So this 8 has to go over here. Since we're dividing by 8, in order to get that to move to the other side, I do the opposite, the inverse. I multiply both sides by 8. And 8, remember, is the same thing as 8 over 1. And we do this because these are going to cancel each other out. If you didn't realize that, you can just multiply straight across and get 8a over 8 is equal to 8 times 4, which is 32, over 1 times 5, which is 5. Sweet. Now these are going to cancel each other out, and I'm left with a is equal to 32 over 5, which you can write as your answer, or you can make as a decimal 6.4. Here we have P to 120 is equal to 1 to 24. Now again, this is still a proportion. It's just not written as fractions. What we want to do, since we're solving it, is we want to write it as fractions. So we have P over 120 is equal to 1 over 24. Now we're ready to go. So step 1, simplify. Can we do that? No. Step 2, variable on the left. Done. Step 3, constants need to go to the right. So this 120 has to go over here. Since we're dividing by 120, to move it, I have to do the opposite, the inverse. I multiply both sides by 120. Remember, 120 is the same as 120 over 1. And we do this because we have a fraction here, so it's easier. You could notice that these are going to cancel each other out right away. Or if you didn't, you multiply straight across, and it still looks like this. Now you see they're going to cancel each other out. And over here, 120 times 1 is 120. 1 times 24 is 24. Now we get P is equal to 120 over 24, which simplifies to 5.
Oh, I don't feel so well. I can't hear a heartbeat. I can't hear a heartbeat. You try.
So we're doing the same thing here. The only difference is that we're asked to round answers to the nearest hundredth if necessary. So we want to simplify all the way. We don't want to leave our answer as an improper fraction. So multiplication property equality, we are going to solve it like usual. Simplify, move, solve. Can we simplify? No. Step 2, variable on the left. Done. Step 3, constant needs to go to the right. How do I do that? Dividing by 5, we got to do the opposite. We got to multiply both sides by 5. Now 5 is the same thing as 5 over 1. And you could notice that these are going to cancel out right away. And you just get x is equal to 5 times 3 over 1 times 4. Or if you didn't, you multiply straight across just like you normally would. Now you see they're going to cancel each other out and you get x is equal to 15 over 4. Now normally I'd let you leave it like this, but in the instructions it says round answers to the nearest hundredth if necessary, so we need to divide this. We end up getting 3.75. Here, we have 3/16 is equal to y over 12. Now again, simplify, move, solve. Can we simplify either side? No. So we continue. Step 2, we need to get variables on the left. So our y that we're solving for needs to go to the left side. So we flip this equation, done. Step 3, constants need to go to the right. So this 12 has to go over here. Since we're dividing by 12, I do the opposite, the inverse, I multiply both sides by 12. Now I do that and you see that these 12s are going to cancel each other out and we just get y is equal to 12 times 3 over 1 times 16. If you didn't see that, you can multiply straight across like you normally would, and now you see they're going to cancel each other out and we get y is equal to 36 over 16. Since we're around the nearest hundredth, we divide this in our calculator, we get y is equal to 2.25. And then here, we have q to 8 is equal to 10 to 3. Now, we want to rewrite this as a proportion with fractions. So we do that, q over 8 is equal to 10 over 3. Now we can solve, so we simplify, move, solve, simplify, done. Step 2, variable on the left, done. Step 3, constants need to go to the right. So this 8's got to go over here. Since we're dividing by 8, I do the opposite, the inverse. I multiply both sides by 8. These are going to cancel each other out. If you didn't notice that, then you can just multiply straight across like you normally would. These then, you see now, cancel each other out. Over here, 8 times 10 equals 80. 1 times 3 equals 3. Now we get q equals 80 over 3, which we then divide in our calculator and get approximately 26.67 if we round to the nearest hundred. Now example 3 says solve each proportion using the cross product property, round answers to the nearest thousandth when necessary. So here we have our proportion. When it says using the cross product property, what does the cross product property say? It says that all we do is multiply across and set those products equal to each other. So we're going to do x times 7 is equal to 12 times 5. So what's x times 7? That's 7x is equal to 12 times 5, which is 60. Now to get x all by itself, I solve like I normally would. So now we simplify, move, solve. So we can't simplify, variable on the left, done. Constant needs to go to the right. So instead of 7 times x, I do the opposite, the inverse. I divide both sides by 7. These cancel each other out. I get x is equal to approximately 8.571. Okay, it's a little easier than using the multiplication property of equality. We can just use the cross product property. Part B, we're again using the cross product property. So we're going to multiply 8 times y and set that equal to 4 times the quantity, y plus 3. The thing that everybody messes up here is they multiply the 4 times the y, but it has to multiply to the 3 as well. You are distributing this 4 to the y and to the 3. So it's going to look something like this. 4 times the quantity, y plus 3, is equal to 8 times y. Now we're going to simplify, move, solve like we normally would. So step 1, simplify. Can we simplify either side? Yes, we can simplify the side using the distributive property. So we're going to do that. 4 times y gives me 4y, and then 4 times 3 gives me 12. Now we're going to move variables to the left. So I'm going to subtract 8y from both sides because it's positive 8y. Just move it over here. I do the opposite, the inverse. I subtract 8y from both sides. These cancel each other out, and then 4y minus 8y gives me negative 4y. Now I got to move my constants to the right. I start with anything added or subtracted to my variable. So I start with this positive 12, so plus 12. What's the opposite? I subtract 12 from both sides to move it. These cancel out. I'm left with negative 4y is equal to negative 12 because 0 minus 12 is negative 12. Now lastly, to get y all by itself, I got to move this last constant to the right. So instead of negative 4 times y, I do the opposite. I divide both sides by negative 4, and these are going to cancel each other out. And I get y is equal to, what's negative 12 divided by negative 4? Positive 3. Part C, we have 8 to z is equal to 2 to 15. Again, it's a proportion, but not written as fractions. So we want to write those as fractions. Now, cross product property. We're going to go 15 times 8 is equal to z times 2. Now, we have our equation. We want to solve for z. So simplify, move, solve. Simplify. No, can't simplify. Step 2, variable on the left. Yeah, let's flip this right away. Step 3, we want to move our constants to the right. So we just got to move this 2. How do we do that? Well, it's 2 times z, so I'm going to do the opposite. I divide both sides by 2. These cancel out. I get z is equal to 60, and I'm done.
Why couldn't the dad figure out his child's temperature? Because he was using a thermometer. You try.
Okay, again, cross product property. We're going to go 50 times 20 is equal to 26 times f. Boom. Now we simplify, move, solve. Can we simplify? No. So we move to step 2, variable on the left. This is our variable. Right away, we can just flip this equation. Sweet. Now our variable's on the left. So step 3, constants need to go to the right. This 26 got to go over here. Since 26 times f, I do the opposite, the inverse. I divide both sides by 26. These cancel out. I get f is equal to approximately 38.462. Part B, we're again using the cross product property. So we're going to multiply q times 15 and set it equal to the quantity q minus 8 times 20. So now that we've done that, we simplify, move, solve. Can we simplify this side? No. What about this side? Yes. Not inside the parentheses, but we can distribute this 20 to the q and to the negative 8. So we end up getting 15q is equal to 20 times q, which is 20q, minus 20 times 8, which is going to be 160. Now, simplify, move, solve. Done simplifying. Next step, move. We want to move the variables to the left. So this guy has to go over here. How do we move this positive 20q to the other side? We're going to do the opposite, the inverse. We subtract 20q from both sides. These cancel each other out, and then 15q minus 20q is going to give us negative 5q. Now this stays negative 160, so we bring that down. Simplify, move, solve. We're not done moving. We need to move the constants now. Move all the constants to the right. So this negative 5 has to go. How do we do that? Well, it's negative 5 times q, so I'm going to do the opposite. We divide both sides by negative 5. These cancel each other out, and when we divide, we end up getting q is equal to positive 32. Here, we have 19 to 21 is equal to m to 49. Now again, they're not written as fractions, so we want to do that. Now we can use the cross product property, and we end up getting 49 times 19 is equal to 21 times m. Now we simplify, move, solve. Can we simplify? No. Can we move? Yeah, we got to move the variables to the left. So let's take this guy, move it to the left. We just switch this equation. Since we move the variables to the left, now we move the constants to the right. So we're going to take this 21, move it over here. How do we do that? Since it's 21 times m, we do the opposite, the inverse. We divide both sides by 21. These cancel out. We get m is equal to approximately 44.333. Word problem. It says a farmer is tasked with picking strawberries. She has been working for 2 hours and has picked 124 strawberries. If she has 248 strawberries left to pick, how long will it take her to pick the remaining strawberries? So we're assuming she's working at that same rate. Step 1, in a word problem, we're not scared. So step 2, what are we looking for? What does it want us to find? It wants us to find how long will it take her to pick the remaining strawberries. So based on that, we're going to define our variables. So how long will it take? So that's the amount of time. So we're going to go t is equal to time to pick the remaining amount of strawberries. Now we can write our equation. What do we know? We know that she has 248 strawberries left to pick. We also know that it's taken her 2 hours to pick 124 strawberries. So this is kind of looking like a proportion. We could set this up. 2 hours to every 124 strawberries is equal to the time remaining t over 248 strawberries. Sweet. Now I have a proportion that I can solve. So again, there's 2 ways to solve a proportion. One would be the multiplication property equality. The other would be the cross product property. In this word problem, I'm going to do the multiplication property of equality. Next one, we'll do the cross product. So this one, multiplication property of equality. We're just going to solve it like we normally would any other equation. We simplify, move, solve. So step 1, simplify. Can we simplify this side? Yeah, we can actually divide each of these by 2 to simplify, and we end up getting 1 over 62. Now we're going to move. We're going to move the variables to the left. So we're just going to switch this equation. Next, we can move the constants to the right. So this 248 has to go over here. How do we do that? Well, since it's divided by 248, I do the opposite, the inverse. I multiply both sides by 248. Remember, 248, same thing as 248 over 1. Now it's easier to see that these are going to cancel each other out, or you could just multiply straight across, however you want to do it. Now you can see that these are going to cancel each other out. And then here, 248 times 1 is 248. 1 times 62 is 62. So I end up getting t is equal to 248 divided by 62, which is equal to 4. Do not leave this as your answer. Your answer must be a sentence. How long will it take her to pick the remaining strawberries? It will take her approximately 4 hours.
Does an apple a day really keep the doctor away? Only if you have really good aim. You try.
Okay, this says, according to a recent study, 7 out of every 500 teenagers still say the word "bay" regularly. In a group of 350 teenagers, about how many would you expect to still say "bay" regularly? Step 1, in a word problem, we're not scared. So step 2, what are we looking for? What does it want us to find? It wants us to find about how many would you expect to still say "bay" regularly. So about how many teenagers. So we're going to define our variable based on that. We're looking for the number of teenagers. So we'll say T are the number of teenagers who still say "bay" regularly. So with that variable in mind, we can write our equation. Do we have any totals or anything? Well, we're looking in a group of 350 teenagers. So that's going to be on one side of the equation. We are also given that 7 out of every 500 teenagers say it. We want to know, based on that ratio, what would the amount of teenagers be in a group of 350 teenagers that would still say it? Oh, this is looking like a proportion problem. So we're going to go 7 out of every 500, so 7 over 500 is equal to T, which is the number of teenagers who still say "bay," over the total, which is 350. We have our proportion. We can use the multiplication property of equality or the cross product property. Last one we used the multiplication property, so let's use the cross product this time. We're going to multiply 350 times 7 and set that equal to 500 times T. Now, all we have to do is simplify, move, solve. We got a regular equation, so we simplify. Can we simplify? No. Can we move? Yeah, we got to move this variable to the left, so we're just going to switch around this equation. Now our variables on the left constantly need to go to the right, so this 500 has got to go over here. Since it's 500 times T, I do the opposite. I divide both sides by 500. These cancel out. I get T is equal to 4.9. Now, what are we asked? We can't leave this as our answer. What's the question? It says, about how many teenagers would you expect to still say "bay" regularly? We can't have 0.9 of a teenager, okay? So what we're going to say is about 5 out of every 350 teenagers still say "bay" regularly. And then you're done.